Hey guys, we're moving on to our next unit. We're looking at sensation and perception now. And for this first module, Module 16, just some kind of basic background information on sensation and perception. Sensation and perception is all about the relationship between stimuli and our brain. Okay, so we first take in stimuli through our senses essentially, and we'll go through the eyes and all that kind of stuff. Um, just like I gave you the handouts in class. So the taking in, as it says, of raw sensory information, which essentially just boils down to like waves of light and sound um, that our specially adapted organs take in, and then that raw data goes into our brain, and then perception happens. Our brain makes something useful of it. Okay, so it takes in, all you're just being bombarded constantly by stimuli, but your brain is so amazing at it, you don't even really think about all the information that's being processed at any given time through your skin, through your eyes, through your nose, and your ears. Um, and you just take it in, and your brain kind of makes sense of the world around you. Okay. Now, when it comes to perception and processing, there's kind of two main ways this happens. So, the first is bottom up. Okay, and this is parts to the whole. So this is data driven. This is things that start from the outside, basically, from your sensation. Okay, so it's stimuli. So I'm seeing something I've never seen before. Okay, and it's I'm looking at it. My eyes are bringing in data, and my brain doesn't really like have any preconceived notion. So it's all just this raw data that's driving the analysis of my brain. Okay, so it's the parts that I'm seeing, and then the whole that my brain is constructed is basically based purely on the raw data that's coming in. Okay, so it begins with outside sensation, outside stimuli coming in, and then your brain's trying to figure out what's going on. Okay, so I've never made something before, and then I have all these ingredients, and now I have to try to like combine them together to make something. So I'm seeing all these things, and I'm like, oh gosh, like what do I do with all of this? And then my brain's gonna try to make some sense out of what I'm doing. Okay, versus top down. So this starts in your brain. Okay, so it's conceptually driven that you have this expectation. Okay, so something that you have prior knowledge about. Um, you're going into someplace familiar. You've been there before, and you already have kind of a preconceived notion of what you're going to see when you get there. Your brain is already kind of filling in the blanks, even though it hasn't even taken the data yet necessarily, or that once it has taken in the data, it's using preconceived notions of compiling that. Okay, so kind of the cooking example. You taste something, and your brain, like your grandma's famous cookies or whatever, and you have that cookie, and you've had that cookie before, and you know what it's supposed to taste like, and you bite into it. You have this preconceived notion of what it's supposed to be, and you're like, something's wrong. Like this doesn't taste right. Your brain already has it, and then you like try to work backwards of like, I wonder what could be missing from this recipe. That's not making this cookie taste right. Okay, so bottom up begins with the external stimuli coming in, and then your brain compiling it. Top down starts, with your brain. I guess so. Figure like the brain is above the eyes and the ears and everything, essentially. Um, so it starts bottom up, starts like with the senses down here, then works its way up to the brain. Top down starts with the brain, and then works its way and interacts with the senses because you already have that preconceived notion. Okay, so this is a good example of top down processing. All right, your stimuli like your eyes and stuff. If this was a foreign language, if you were looking at Greek and you had no idea what Greek was, and the letters of Greek were all messed up, like you'd just be like gibberish to you. But since this is in a language you're already familiar with, okay, and you already have this preconceived notion, your brain can compile all this basically nonsense into a meaningful experience because your brain kind of knows what according is supposed to look like and research is supposed to look like and Cambridge is supposed to look like. So even though it's all jumbled, your brain can kind of make sense of it and complete the parts, even though your sensation is like your eyes are like, what the crap is this? Okay. So here's another example. It's top down, bottom up. Which one is it? Well, it's both. Okay, because your brain already has preconceived notions of what it's supposed to look like, but then your sensation comes in and sees like, oh wait, this is something. There's two people here and there's playing guitar. So it's kind of working both ways. That's why you can see all these different images. Your brain already has like, okay, these are two people. That's what they're supposed to look like. But then your sensation is like, wait, something's different here, and it's triggering the bottom up as well. Okay, it's kind of why those optical illusions work. Selective attention, focusing only on a particular stimuli, okay, can influence your processing. This is a very famous scene from Psycho, the first Psycho, where a skull was superimposed on one of the people's face to make them look more menacing, but it happened just sort of like a split second. So people were focusing on the face, and that's where their attention was, and didn't notice the extra stimuli consciously, but it actually kind of triggered fear response in them, so they were like slightly more afraid of the person, even if they didn't even realize why, because they're only focusing on a particular stimuli, selective attention. Okay, so how we focus on things, what catches our attention, what stimuli do we pay attention to, basically depends on the thresholds. Okay, so like for that last scene here, this happened so fast it was below the absolute threshold here for people to kind of notice it for the most part. Some people might have, but for the most part, it flashed up there for just like a one frame and didn't even really pick up on it that even happened consciously. Okay, so your absolute threshold is the minimum amount of stimulus needed to detect, for your detection to happen. All right, so you put your headphones on and you turn the sound all the way down, and you're kind of, okay, now I can hear it. Okay, that's your absolute threshold. And obviously it varies depending on the person. Some people have better eyesight, some people have better hearing. So it kind of depends on you individually what your absolute threshold is, but an absolute threshold is the earliest time that you can detect it. Okay? And the difference threshold is the minimum difference between two stimuli that can you detect. Okay? So you're listening to headphones and indicate when you can actually hear a change to the sound of volume. All right? So basically I know like this, these two stimuli, so you have a cup, and there's like two weights inside of it, but you can't see it because the cup is closed. So your difference threshold is when you'll be able to pick up and be like, yeah, these are two different weights. It's like clearly no. They're two different weights 50% of the time if you're doing this in a study. Okay? And what determines that difference threshold is basically Weber's law. That the difference proportional the difference threshold is proportional. So, and the stronger the stimuli, the harder it is to detect the change. So again, I have two weights. I have a 5-pound weight and I have a 10-pound weight. So they like look the same, but they're just different densities, so they're different weight. So I can't visually see that's bigger than others. They look the same, and one's 5 pounds and one's 10 pounds. Well, it's a 5-pound difference, but if I pick up the 5-pound weight and then I pick up the 10-pound weight, chances are I'll be like, oh wow, that's definitely heavier. Okay? Versus if I had two weights that look the exact same as well, but one is 200 pounds and one is 205 pounds. It's still only a 5-pound change, just like the 5 and the 10-pound, but since it's proportionally a lot, less of the overall stimuli, I doubt very highly to pick up a 200-pound weight at 205 and be like, oh yeah, that's clearly, this one's 5 pounds heavier. You'd probably never know the difference. Okay, so the stronger the stimuli is, the harder it is to detect the difference there. You would need a more drastic change, like this is a 200, now this is a 300. Okay, yeah, or a 200 and a 250 probably. But just 5 pounds probably wouldn't cut it at that point. And then sensory adaptation. The more you are, consistently exposed to that stimuli, the less you'll pay attention to it. Okay, so there's a clock in your house that makes the click 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 sound. You know, if you have it in your house all the time, you probably would notice it because you're so used to hearing it. Your brain is just like, all right, there's that kind of background clicking noise, and we're not going to really pay attention to that. Versus someone who, you know, someone who gets in, the house for the first time, it's like, what is that clicking noise? Like, because they're not used to it, or it being, close to summer, getting in, you jump in that pool for the first time, right? We've all done that. You get in the pool and it's like freezing cold, and you're like, oh my gosh, oh my gosh, oh my gosh, oh my gosh. But then eventually you get used to it. Well, what happened? Well, you're still 98.6 degrees. The water is still basically the same. You're adding, your body heat hasn't like all of a sudden warmed the water now to this nice pleasant level. It's still really cold, but your skin, because it's constantly bombarded with this cold, 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 eventually it's like, all right, we get used to it, and your receptor cells fire less frequently, because you get that diminished sensitivity to it. Okay. So the signal detection theory picks up that as we have a background constant stimulus, okay, it detects how we'll be able to detect the presence of another stimulus that's faint. All right. So a lot of things can change the signal detection theory, your motivation level, fatigue, expectations, and stuff. So again, you're in a crowded place and you're waiting for someone. You're in some place like a restaurant. And there's a lot of noise or whatever. So your back is to the door, and you're expecting someone that you really like, or someone who matters a lot to you is coming. You're probably going to be focusing. If you hear their voice, probably a lot easier because you're focusing in on it. You're like, you're ready to go. You're waiting for them. Like, oh yeah. Versus someone, if you're tired or you're like you don't really care, you might not be able to pick up that signal or that other stimuli as much as frequently as you would if you had higher expectations and so on. Okay, and some things that can influence the perception. That this kind of goes along with our last one here, the cocktail party effect, your ability to focus on a single voice in a crowd. There's all this stimuli around you, but your brain can filter it out and be like, oh, that's the voice that's familiar to me, or I heard my name, or something that's keying me in to a singular sound in a room full of noise. And then perceptual set, okay, is the bias you have of certain perception over another. So as you take in stimuli, the way that your brain perceives it can change depending on your preconceived notions. So it's like the one we did in class. So if I had a three-letter word and two letters are blank, and then there's an E in the middle, what? And I say, what word is this? Okay, and I give you nothing that makes you biased toward any certain word. You might come up with a lot, but if I go green, blue, purple, and I have line, I say, what word is this? Everyone's like red, because I've already made you more biased toward color. Or if I put 1, 2, 3, 4, blank, E, blank, 10. So now I'll have you biased toward numbers. Okay, so we all have our pre-existing ideas and concepts and beliefs. So as we bring in, our stimuli, sometimes we perceive them in different ways depending on what we already have, that top-down processing kind of kicking in. Okay, so these are some basics of sensation perception. Make sure you guys are doing the reading in the book and staying with that. And let me know if you have any questions.